Hey, how's it going, guys? Your friend Jim here with another video. As you saw in the intro, this video is going to be about the EGR valve, the EGR system. We're going to talk all about this little guy, this valve right here. This is a known good functioning EGR valve, but we're going to talk about it. We're going to go into details, checking the resistance on the little stepper motor in here, and also checking the voltage on the wires coming connected to this guy. So since it's a known good known good system, you can use this as reference when you have an issue with your vehicle. If you ever have an issue with your vehicle and you're getting a P0401 or a P0403, which are the two DTCs pertaining to the EGR system on the Montero. Anyway, welcome guys to the Mitsubishi Montero channel. I greatly appreciate it, and if you haven't subscribed to the channel, please go ahead and subscribe. Go ahead and like the video, share the video, and also hit the notification bell so you can get notified every time I upload a video. As I said before, I don't upload a lot of videos, but when I do, I like to make them really good quality. Well, again, not good quality, but maybe not the best of quality, but at least very informative. You have all the information that you need on a specific system of the Montero. So sit back, relax, crack open a cold beverage, and enjoy the video. Let me know if you have any questions or comments down in the comments below, or if you just want to say whatever, just let me know, and I'm happy to interact, happy to reply to you guys. I do enjoy the interaction. So yeah, let's go ahead and move forward and go from here. Alright guys, so here's the component system diagram on the Montero. It's got all your inputs and all your outputs, sensors, actuators, just a bunch of different things pertaining to the 3.8 liter Mitsubishi Montero, which obviously it applies to 2003 through 2006 in the United States. On this diagram, the EGR valve is right here, and as you can see, there is a little tiny tube here that runs from the exhaust up to the EGR, and then after the EGR there's a little passage that goes into the intake manifold. This little tube that comes from the exhaust basically is this guy right here. You guys are familiar with that little guy right there. Whenever the computer commands the EGR valve to open, exhaust gases flow through the EGR passage into the intake manifold, and it goes back into the intake manifold, and these gases that come from the exhaust are what they're known as inert gases. They don't burn. They're just taking up room in here with the other gases that are about to be burned. And the reason for that is because those gases will reduce the temperature in the combustion chamber during combustion, and I will talk a little bit more about that later because that's an important fact. Now, so when the computer commands the EGR valve to open, there is an effect on the intake manifold pressure, and the map sensor relays back to the computer with that change, confirming to the computer that when the computer engaged the EGR to open, there was a change in the intake manifold pressure, and that's how the computer confirms that there was actual EGR flow. If the computer turns on the EGR and nothing happens to the map sensor, then the computer determines there is no flow or there's insufficient flow, and that's when you get the P0401. We'll talk a little bit more about that later. So that's the map sensor is very critical in this particular system. Some other vehicles, they have a temperature sensor, because obviously you have hot gases flowing through here, so that temperature sensor confirms to the computer. This one doesn't have that. This one has the map sensor to tell the computer that there was EGR flow. Alright guys, so let's continue talking about this here. So in this case, we're going to talk about just a little bit of basics on emissions and the gases that come into the engine and come out of the engine. This is obviously in Spanish, but don't worry about it, I'll say it in English. So this is an illustration. The ambient air here goes into the engine. We have combustion, comes out of the exhaust. Okay, so in the atmosphere we have 78, the content of the chemicals that are in the elements that are in the air, 78% of that is nitrogen, 21% of that is oxygen, 1% is other gases. Oh, damn it. Sorry about that. Okay. 1% is other gases. Within that 1%, just in case if anybody's curious, we have 0.04% CO2. So in the atmosphere on planet Earth, 0.04% CO2. Ever since they started measuring, it's never changed. And it probably has changed from time to time, but the more CO2, the greener the Earth is. Just throwing that out there. All right, just throwing it out there. All right, so so coming out of the exhaust gases, we have oxygen, we have carbon dioxide, we have carbon monoxide, hydrocarbons, and oxides of nitrogen. The EGR valve, the valve we're talking about today, controls this guy, regulates this guy. Carbon dioxide, oxides of nitrogen, I mean. If this gas is too high, your vehicle will not pass smog. I have an example here of a smog check result for my Chevy truck. And as you can see, we have CO2, we have O2, hydrocarbons, carbon monoxide, and NO. This NO is oxides of nitrogen. And if you have a malfunctioning EGR, this guy will be too high and your smog check will not pass. So that is the purpose of the EGR valve, to control oxides of nitrogen. That gas right there. Alright guys, so here we are at the Montero. As you can see, we have the EGR valve right there. It's right here. So here's the if you look at it from this angle, you'll see it right there. This is the EGR valve. Here's a 6-pin connector right here. You can see two red wires in the middle. Those are the two power supply wires that come from the MFI relay, and we'll do some voltage tests on that right now so you can see what normal is. Key on, engine off, idle, and 2000 RPM, so that way you can reference it as normal. Now, as I was saying before, when the computer commands the EGR to open, oh, and also there's that little EGR tube down there that I showed you. So when the computer commands the EGR to open and there's EGR flow, there's going to be a change in pressure inside the intake manifold. That change in pressure, the map sensor, which is right here, the map sensor tells the computer, yep, there was a change in pressure when you open the EGR, and that's how the computer confirms that the EGR is actually functioning. So map sensor plays a very important role in this EGR setup here on the Montero. On the Gen 3 Mitsubishi Montero, there are two, as the computer monitors the function of the EGR valve system, there are two possible DTCs that might set. We have P0401 and we have P0403. We have it right there, P0401. P0401 is an exhaust gas recirculation DTC, insufficient flow detected. P0403 is exhaust gas recirculation control circuit. So there are two different codes. One of them is a functional code, the other one is an electrical malfunction code. All right, so starting out here with P0401. P0401 is it's exhaust gas recirculation flow insufficient detected. That's what it says right here. That's what it says right here. So basically, it's just the computer commanded the EGR valve to open. It didn't see enough reaction from the map sensor, and it says not enough EGR flow. And that's basically what this DTC is. Again, this DTC is not an electrical DTC. It's not caused due to too much current or not enough current. It is caused by insufficient EGR flow based on the reaction of the map sensor when the computer commanded the EGR valve to open. There's a few things that need to be met before this condition occurs. Certain conditions have to be met. I won't go through all of these conditions. You know, basically it has to reach normal operating temperature. The RPM has to be within a certain range. And then once it enters, once it meets those conditions, and the computer enters monitor mode. And basically this is very simple. What it does, it looks at the map sensor, opens the EGR valve, looks at the map sensor again. It compares map sensor reading 1 to map sensor reading 2, and there has to be a difference. The difference in value has to be greater than predetermined value. If it's less than that predetermined value, then that's when the computer sets the P0401. Now, we're probably never going to get to the point where you measure this, but if you do, here is that predetermined value. The predetermined value is 0.74 inches of mercury, or 2.5 kilopascals. So the map sensor change has to be greater than that in order for it to pass the monitor. If it's lower, then it's insufficient flow, and it sets the P0401. So as I had mentioned before, when you have the P0401, we have to make sure the EGR passages are okay. Starting with this little tube coming from the exhaust side, it goes into the intake manifold right after. Here's the throttle body, so it comes in right after the throttle body in this area here, and then it goes through the EGR into the intake manifold. So once you get the P0401, you have to make sure that the EGR passages all throughout, from the exhaust to the intake, are clear. Any obstructions there will give you the P0401. All right, let's keep going here, guys. And then the next DTC would be the P0403. So P0403, this is an electrical circuit code based on the EGR circuitry. So let's go ahead and talk a little bit more about that. Okay, so let's talk a little bit about the circuit, the EGR circuit here. As you can see, we have the wiring diagram here. We have the 6 wires at the EGR, which is these 6 guys right here, the connector. We have the 2 in the middle, which is terminal 2 and 5. 2 and 5, 1, 2, 3, 4, 5, 6, and we have them right here. So terminals 2 and 5 are red wires. They're a little bit thicker than the other ones, and these wires get power supply from the MFI relay. You turn the key on, computer turns down the MFI relay, and we get power on these 2 wires. These 4 wires that go from the EGR to the computer are obviously what the computer uses to control these little stepper motors. And I'll zoom in a little bit so you can see the little stepper motors in there, little coils, and the computer uses the transistors down here to make those control that. And I did check the ohms on these little on each one of these motors. So I went from 2 to 1, and we got 22 ohms, 2 to 3, and we got 22 ohms, and then we went 1 to 3, and so it's basically total resistance. So 22, 22, 44. Same thing with the other side, 22, 22, 44. And this is just as a reference. So if you have a malfunctioning EGR and you're suspecting maybe there's a short circuit inside or an open circuit, well, these are normal readings, because I know that EGR right there is a known good functioning EGR. So if you have a P0403, this is the judgment criteria the computer uses. It says start, monitor conditions, yes. Was surge voltage detected? Yes, good, no, malfunction. What the hell are they talking about there? Basically what they're talking about is whenever the computer activates the MFI relay, it gets voltage on terminals 2 and 5, and then these terminals, since the computer is not activating the EGR right now, these 4 terminals, the computer must see 12 volts on each one. If it doesn't see 12 volts on each one, then the computer will give you a P0403. Also, when the computer is activating these wires by grounding these transistors, the computer is able to detect if there's not enough current flow or if there's too much current flow. And that's another judgment criteria. Either way, it'll blame the circuitry and it'll give you the P0403. So if we go through this inspection, it gives you the judgment criteria here. It tells you to check certain things, check the connector, measure the resistance, which we did a little while ago, and here's the standard value, 20 to 24 ohms, and we got 22, so that we know that's normal. And then it just has you check the harness, check the connections between the computer and the EGR, check the MFI relay, just basic things like that pertaining to the circuit. There's one more test that they want you to do. Here's the continuity between the computer and the EGR, continuity or short. So you got to make sure that the wires are not open between the computer and the EGR, or shorted to ground, or shorted to each other for that matter. Another test that they're talking about here, which is pretty curious, is this guy here. One of the tests, step number 9 on the inspection flowchart here, is they want you to apply power and ground to the EGR and make sure it moves. Come on, focus. Okay, there we go. So they're saying get the jumpers. They have a tool number here, but I'm pretty sure you can rig some little jumper wires here. Apply the power and ground, and then jumper wires, and then check to ensure the motor operates when the terminal. Okay, so basically you're just activating to make sure that the voltage, that the actuator moves inside the EGR. It says vibration should be present at each application of voltage to test clip combination. So that's basically all you're doing. I guess you can do that. It's on the test to make sure that the EGR is not only electrically okay, because if you check the coils, the motors ohms, then you can tell if the coils are okay. But this test is to see if it's mechanically okay and it's mechanically able to move, which I guess it would be a good test if it comes down to it and there's a lot of carbon buildup in there and you do this test, it's not going to move. But obviously if you do a visual inspection, clean out all the carbon buildup in there, that's gonna take care of it. So just one other thing to check, one other thing to keep in mind if you are going through this. A lot of people don't get this far in the diagnosis. They just throw a new EGR valve in there and they call it a day. So, but if you go through the flow chart, that's basically what they want you to do. Anyway, guys, all right, so let's keep moving here. All right, so now we're gonna check the voltage on each one of the terminals here at the EGR valve. We do have the 6 terminals. We're gonna check the voltage on each one of the terminals at key on, engine off, at idle, and at 2000 RPM. And we're going to write them down on a piece of paper and we're going to go over them inside. And again, this is just for your reference if you're diagnosing a P0403, because everything is functioning normal in this Montero. So whatever voltage we get would be helpful for you if you're diagnosing and you're doing this job. You'll know what normal is, and then you'll be able to compare to your results. So I'm not going to be able to back probe these wires because it's the rubber in here, it's a little bit dry and hard. So I'm just going to prick the cables one at a time with this probe, being very careful not to overdo it when I prick them, and then I'll get a voltage result on each one of them. I know a lot of people don't recommend to do that. I've done it for years and years. I've never had any issue, as long as you're careful when you're probing it. So let's go ahead and move forward with this, and we'll go over the results once I'm done. All right, so here we have the results of our voltage test. Now remember, we have the 6 terminals right here. We have terminals 2 and 5. These are the power wires coming from the MFI relay. Terminals 1 and 3, we have the 1 stepper motor, and terminals 4 and 6, we have the other stepper motor. We checked the voltage at key on, engine off, at idle, and at 2000 RPM. All right, so we're just gonna go wire by wire. Terminal number 1, key on, engine off, we have 0.22 volts. At idle, we had 13.7 volts. And at 2000 RPM, we have 13.9 volts. Terminal number 2 has battery power at all times. Terminal number 3, we have 12 volts at key on, engine off, and we have 0.2 volts at idle and at 2000 RPM. Terminal number 4, we have 12 volts at key on, engine off, 0.2 volts at idle and 2000 RPM. Terminal number 5 is power all the time from the MFI relay. Terminal number 6, we have 0.2 at key on, engine off, and 13.8 or battery voltage at idle and at 2000 RPM. So as you can see, the stepper motor is functioning, and that's how the computer controls it. The voltage is just, with the voltmeter, it's just a fixed voltage. You can't check, you can't see the changes and how the computer is controlling that stepper motor, because it happens so quick that the voltmeter doesn't have a way to give you that change in value. For that, you would need an oscilloscope, but at least it gives you an idea of what is going on with these circuits in these 3 conditions. So again, just for reference purposes, that's what you would use this information for. Alright guys, so this pretty much concludes the video. I hope you guys enjoyed the information that I provided, P0401, P0403, and also this small emissions control lesson that I provided. Please like, share, and subscribe to my channel, and I will see you on the next video. Thank you so much. Please leave a comment down below if you have any questions or comments. I greatly appreciate that. See you guys on the next one. Bye.